All right, another question. So we see Venus, Earth. All right, so it's basically a Kepler's planetary law of motion based problem. One of IBDP's favorite. Again, IB has been asking questions based on Kepler's planetary law of motion, specifically third law of motion, because that's the one law from based on which most of the numericals you'll find. So this question is based on that, and on top of it, this concept is very prominent in paper 2 and paper 1 as well. So let's see how we are going to solve this question. So we've been given the orbital period of Venus and Earth. Calculate the ratio of orbital radius of Venus and the orbital radius of Earth. Okay, so if you recall Kepler's third law of planetary motion, square of the time period is directly proportional to the cube of semi-major axis or the radius of the orbit. For us, it's the radius because we are dealing with circular orbits. So I can say t square equals to r cube. I mean, I can write this is being said by the law. So t square is proportional to r cube, which means I can compare the time periods of Venus and Earth. And I can relate it to the orbital radius of Venus and Earth. So tv square over te squared, time period of Venus over time period of Earth, equals to rv cube over re cube. Remember that we are looking for this value right here, not the cube, just rv over re. So I can write this as 225 over 365. Square of this equals to rv over re cube. Or if you take cube root on both the sides, you'll end up with the number on the right side raised to power 2 by 3. And this value is all what we need to calculate. So we'll bring up the calculator. All right, so let's start the bracket. We are looking at 225 divided by 365. Close the bracket and just have to put a fraction in the exponent. So that's 2 by 3. All right, so we just have to calculate this. This comes out to be 724. And then there's an m in the end. So that's 724 times 10 to the power negative 3, the multiplier. So you can write it as 0.724. 724 is good. I believe we are looking at 3 significant figures. So when rounded off, this will be 0.724. So that is the ratio. That's the answer to part A. Explain how observations of the motion of a planet allows scientists to determine the mass of sun. Now, this question right here is something which, almost all of us would have had in the childhood. Like, how did they calculate the mass of sun? Now, interesting part is when you look at this equation right here, you can remove the proportionality sign, and that's where you're going to introduce a proportionality constant. So t square equals to some proportionality constant times r cube. Now that proportionality constant is 4 pi square over gm. Now, at this point, if you look at this proportionality constant, it's made of gravitational constant and the mass of the central body around which other bodies are orbiting. Now, when you are observing a planet, it's orbiting the sun. While observing the planet, you will have the time period, the orbital time period of the planet. You'll also have the orbital radius. When you plug that into this equation, the only unknown you will be left with will be the mass of sun. So you can calculate the mass of sun with the help of this equation. Let's move ahead. A difference between max and mean Earth-Sun distance, this much. Difference between GP is given. Okay, find the average gravitational field strength. All right. So we have the difference in gravitational potential, and we also have the distance between the 2 points. So there are 2 points, and the difference of gravitational potential between these 2 points is known, and the distance between the 2 points is also known. We just have to calculate the average gravitational field. So what we can do is implement G equals to negative delta Vg over delta R. Now, we don't really have to worry about the negative sign because we're just concerned with the magnitude of this. So you can just plug in the values. You'll have 3.0 times 10 to the power 7 divided by 5.0 times 10 to the power 9. So this is 0.6 into 10 to the power minus 2. Units will be newtons per kilogram or meters per second squared. Either of these units will do, and they both are acceptable. So that will be the answer to part C. So I hope you guys understood this pretty well. If you've got any doubts, do let me know in the comments. Thank you for joining, and I'll see you in the next one. Goodbye.